So let's continue to investigate the function f of xy equals y squared divided by x squared plus y squared, this time using some online graphing technology to be able to visualize this graph a little bit more easily. So I'm on D2L and I've gone to the Course Content tab, and I'm going to click under Course Information and Resources, Online Technology Resources, which gives me this long list. And there are a lot of different ones that I could choose, but let's go ahead and take a look at this function using Wolfram Alpha. So I'm looking at the function f of xy equals y squared divided by x squared plus y squared. And Wolfram is pretty forgiving about syntax, so if I ever have trouble, I can always look at an example. Here, it looks like the graph is represented with the x-axis here and the y-axis here, and it looks like when my x value is set constantly equal to 0, my outputs, my z-values, are up along this ridge. The top of this ridge is right where my z-values equal 1, which is what we found before. On the other hand, when I set my y-value exactly equal to 0, I am down at the bottom of this valley, and if I could look a little three-dimensionally, I could see that this valley goes all the way into the 0, 0, which is our limit point, and it maintains a 0 value all the way. Another way that we can analyze this is by looking at our contour plots. They've color-coded these contour plots for us, where the darker values are the values that are lower, and the lighter values are the values that are higher. Again, we can see that when I set my x value exactly equal to 0, my contour line is given exactly by this line, and it's the line where z was equal to 1. Whereas here, on the y-axis, when my y is equal to 0, 0, my contour line is exactly equal to 0. And notice that all of these contour lines are straight lines going into, or maybe emanating from, the origin, the 0, 0. And we see that because one way that we can tell that a limit doesn't exist is by the fact that all of these contour lines are intersecting one another. And this intersection is telling me that all simultaneously, right at this point 0, 0, it's taking on a value of both the level curve of z equals 0 and the level curve of z equals 1 and the level curve of z equals 0.5 all at the same point. And obviously it's not possible for a real valued value to be 1 and 0 and 0.5 all at the same time. And so that's a good indication. Anytime I have contour lines that seem to intersect one another, that's an indication that that point doesn't exist and that the limit at that point doesn't exist as well.